every single positive number can be broken down into a set of prime factors. In fact, even better than that, every single positive number can be broken down into a unique set of prime factors. This is the fundamental theorem of arithmetic, and it's actually pretty useful. So prime factors are used in cryptology to keep data safe. So every number is made up of prime factors. You can think of it as the atoms that make up numbers. So I'm trusting that you know what prime numbers are, and that 2 is the only even prime number. So let's have a look at how we break numbers down into prime factors. We look for prime numbers that divide exactly in. I always look for 2 or 3 first. So 2 goes into 90 45 times. Circle the 2 as it's a prime number. 3 goes into 45 15 times. Circle the 3 as it's a prime number. 3 goes into 15 5 times, and circle both the 3 and the 5 as they are both prime numbers. We've ended up with 2 prime numbers, so that means we've finished the prime factor tree. So the prime factors of 90 are 2 times 3 times 3 times 5, which we can also write as 2 times 3 squared times 5. If you don't like using a prime factor tree, maybe you'll prefer using the list. 2 goes into 90 45 times, 3 goes into 45 15 times, 3 goes into 15 5 times, 5 goes into 5 once. Just make sure you always end up at 1. So the order of prime numbers that you choose doesn't really matter. You'll always get the same answer. So we could have done it this way instead. And we still get 2 multiplied by 3 squared multiplied by 5. Your turn. Pause the video, work out the answers, and click play when you're ready. Did you get them right? So that's all there is for finding prime factors. If you're using the prime factor tree, just remember to keep going all the way until you end up with 2 prime factors. Or, if you prefer the list, keep going all the way until you end up at 1. In another video, we'll discover how to use prime factorisation to find the highest common factor and the lowest common multiple really easily, even for massive numbers.